Hello?
Hello, sir.
Yeah, can you see? Yeah, I've started recording also. Okay.
Yes.
So the communication network in the smart grid will involve communication network in smart grid has a hierarchical structure. So the number one thing that comes into our mind is the premises network. So in the premises network, you have number one thing is your home area network. Home area network, that is your basically your hand. Okay. Then you have another thing that is called as your, tell me, you had written down the building area
It's a
network.
ban, sir. Building
Building,
a network.
yeah, building
A network.
area network.
And then
Okay.
industrial area network.
And then you have this is called ban, and you had the
Area network.
industrial area network. So okay. So now what happens is that after this, you another network that is called as the neighborhood network. Okay, in the premises network, you have a network that is called the neighborhood. Okay, this is your near your home. Then this is the neighborhood network. This neighborhood network is called as NAN. It's called as NAN,
So
and
that's also part of the premises network.
yeah, that's also the part of the premises network. So you basically have the premises network. Okay, and this premises
Yes, sir.
network comprises of uh, your home area network, building area network, and the industrial area network. Then you have
Okay.
you see, this is the architecture, how it is functioning. So in your premises network, primarily first thing is your home that is coming into picture. Then is your ban. Okay,
Yes, sir.
ban can see, sometimes ban you can write as business area or the building area as well. Okay,
Okay.
alternatively it can be written as a business area network or industrial area network. And
Okay.
I'll send you a picture on the WhatsApp, because okay, you just look at the picture and you'll be understanding. Okay, on your phone, you have your phone, right? You are studying from laptop, right?
Yes, sir. Yes, sir. I have my phone.
So because I don't know, I don't have the soft copy of the book, so I'll just send you the picture. Look at the picture, okay? Then you will be
Okay, sir.
understanding. Yeah. Simultaneously, I'll just send you this picture. You just go. Yeah. So this is yeah. The phone was little down. I don't know whether picture is clear or not. Can you see the picture?
Yes, sir. Yes, sir.
Yeah, it's clear now.
Yes, yes, sir. I understand. Yes, sir. Yes,
Yeah.
yes, sir.
Yeah. So this is how the networks are looking there. Okay. So this is okay. And then you have the industrial area network. As you can look there, there is this industrial area network. So and the building area network, the ban, or it's sometimes see, alternatively we can say it as the business area or
Yes,
the
sir. Yes.
building area, whatever is, and the industrial area network. Okay, then you have the term there. You can look at the diagram, neighborhood area network. Okay, that you can see the
Yes, sir. NAN, sir.
NAN is there na, in the picture which I have sent you.
Yes, sir. Yes, sir. I can see that.
This NAN is also termed as your field area network. Field area network.
Network. Okay.
This field area network is termed as your FAN, field area network. And finally, you have the term that is your wide area network. So your
Network.
yeah, you can see over there. You have this home area network, business area network, industrial area, neighborhood area. But if you look at the picture there, you will not find any wide area network. Are you able to
Wide
find?
area network. Yes, sir. No, sir.
No, there is no wide area network. Basically, what is the wide area network then? Wide area network is the basically the transmission link that is going between the distribution and the transmission side. And in the distribution and between the see between the generation, in the generation side you can see hydro, nuclear, thermal, wind. That is basically the type of generation, whether it is a hydel power, it's a nuclear or thermal. And between the generation and the distribution, there is a transmission system substation that is controlled by SCADA. So SCADA is governing all the information there. Okay, this information is controlled with the help of a supercomputer. Okay, and from this SCADA system only, you are just transmitting the information to the local load dispatch center. Okay, there is a local load dispatch center. See, load dispatch center would schedule the loads. Okay, generation will just
Okay.
generate it. Okay, then add after generation, like I had shown you in the previous slide, generation will take place. Okay, after the
Yes,
generation,
sir.
now no, that was a conventional system. This is a smart system. In the smart system, generation will take place on the left corner of that figure. You see, generation is taking place, wherein hydro, nuclear, thermal, and PV and wind is written. And
Yes, sir.
down after that, transmission is now. If you look at the transmission arrows are bilateral in structure. They are going both ways. It can go back to the grid or it can come into the transmission line and go to the distribution. There is no
Okay.
one. There is, see, in the, if which you are looking, see, there are both the arrows. One is in both ways. One is in unidirectional. So
Yes, sir.
this unidirectional arrow represents a conventional network. Whereas if you look at the bidirectional network, see, bidirectional network will represent your smart structure. In the smart structure, the energy can be transferred back to the grid or it can be taken to the grid. Just like I told you, your electrical network is there, your batteries are there. You can take the energy from the battery and you can use it when there is load demand. Okay, you can use it
Yes, sir.
to, you can use it to lighten up your office. Suppose
Okay.
you are working in some industry and in that Infosys or some company or like that, and 500 vehicles are coming daily.
Yes, sir.
You are traveling from 25 to 30 kilometers, so the batteries are charged up. So you can use the 50% battery capacity throughout the day to lighten up your grid. It can
Yes,
act
sir.
as it can be integrated to grid. And suppose there
Okay.
is some off day, okay, and your battery is down, you can use that energy stored in the grid and charge your battery. So it is vehicle to grid, grid to vehicle. Okay, and
Okay, I got it, sir.
will happen due to the power electronic interface by varying the duty cycle and battery management system. See, when you talk about this, let me come back to this. When you talk about your battery management system, what does it do? In the battery management system, always in the battery, you have some upper limit. Okay. And you have some lower limit. You have an upper and a lower limit, right?
Yes, sir. Yes, sir. Yes, sir.
If you if you charge your battery beyond this upper limit, what will happen? Battery will get swollen. Okay. And if you continue charging it, then what will happen? Or
Bad for the battery.
it will damage the battery, right?
Correct,
It,
correct,
it,
correct.
it will damage it. Now, if you discharge, this action on this side is the charging action, and in this side, if you look at this side is the discharging action. This is the discharge part. And if you deeply discharge this battery, so this is deep discharge. So when you are deeply discharging it, so what will happen is that it will get deeply discharged and its cells will get worn out. Okay.
Yeah, correct, correct. It's bad for the battery, now, sir.
Okay. Now I will tell you one thing. After 5, 6 to 7 years, our battery, we have to throw the battery. We have to throw it and get new battery and new battery. Why is it so? Because all the battery have certain amount of cycles. They have
Yes, sir.
cycles for charging and discharging and discharging. So one one full cycle, one let me go get back to this. Okay, no issue. One full cycle of battery, one full cycle of battery means one full cycle of battery means what? Can you tell me how battery goes from 0 to 100? 0 to 100, that means one full cycle. Okay.
Yeah.
Okay, so every battery will have 7,000 to 8,000 cycles. When those cycles are over, it is gone. So
Okay.
now let's go back to the hierarchy. So in the hierarchy, you have there another networks connection also. So these network connections, if you look, see, this was about the structure, how it would be in the premises network, how these structures will look. So in that you saw that there are these networks. Now one more important thing regarding the smart grid is that, see, the wide area network will be having a backhaul network, core network, and metro network. So the wide area network means the network which is getting connected to different parts of the country. And that is wherein that wide area monitoring also we were doing was on the wide area network only. When we were placing the PMO, SCADA, EMS system, that happens at the wide area network because we want the information exchange at wide area network only. So the wide area network will include wide area network, wide area. Now, wide area network is not the part of the premises network. It is the part beyond that. Okay.
Okay.
Part beyond the premises. Premises means at that place only. Part beyond the network. So it would include what? It wide area network includes, now I'll tell you, wide area network would include a network called as backhaul network, and you have a core network. Okay, these are the core network, and you have and metro network. So these are the forms of the networks that would be incorporated into the wide area network, and these networks are defined according to their reach. These networks are defined according to their reach and function. Okay, according to their reach and function. So this, am I recording this?
Yes, sir. Yes, sir.
Okay, I'm recording this. So now the communication networks in the smart grid would be defined according to their reach. Okay, where and
Okay.
okay. So primarily, if you see, we had the premises network. Okay, and wide
Yes, sir.
area premises network is one network. Then we have wide area network.
Wider network.
uh then see, premises, after the premises network, this network, see, premises network will comprise of house area, building area, and industrial area. But now after
Okay.
the premises, the second network is your, see, after that, this is premises means the locality. After the locality, you have the second part, that is the neighborhood network. Okay, and then the third part, that is the wide area network. Okay, so
Okay.
these are the three types of networks that will be incorporated in the smart grid. So now we had this, basically, now you look at depending of the okay, now this premises network was divided into how many parts? It was divided into three parts. Premises network was
Correct.
a house area network, business area network, or
So
building
four
area.
parts, sir.
No, only three parts.
So the neighborhood area network also falls in the premises, right?
No. I think when I was just explaining that part, I just wrongly said neighborhood network is not a part of premises. I'm sorry.
Okay,
Like
sir.
in the heat of the moment, it came out of me. Okay, yeah, I'm sorry for that. Neighborhood network is not part of premises. Premises would mean only those. house area, building area, and the industrial area of that locality. And the name itself,
Okay.
neighborhood, it suggests that it's not the part of that. And then the wide area, and I'm sorry for that. Yeah, I remember. Sorry to cause the confusion. It happens
Yes,
sometimes.
sir.
It just slipped out of my tongue. You had asked me also. In the heat of the moment, I did not realize. Now I'm getting okay. Yeah. Now let's get back to the point. Now, if you look at the figure, okay. Now, figure you have looked at the figure 3 point. What is that? Okay. Now, let me send you. Mm, see. Now let me send you
Another
one.
figure?
Yeah, one more figure. I'll send you. Look at that. You just have a look at the figure. If I had got this. Because these pictures and all, if I make it will take another half an hour. So we don't have that much time. Okay, just go.
Yes, sir.
Yeah. Now, this is how I think it is coming. Yeah, yeah, it came now, right?
Not yet, sir.
Yeah, it has
Yes, sir,
come.
not yet.
Huh? It has not come.
Yes, sir.
Yeah,
So it has come now, sir. Came
yeah,
now.
yeah. So now, if you look at the figure, then after that you have this. See, in the wide area network, you have these networks like your enterprise, your substation LAN, core and metro network, and black hole network and substation lane. Okay, so these networks, see now how it is going. See the primarily on the extreme right of the figure, you can see the
Yes,
premises
sir.
network, which comprises of your high house area
Okay, that
network,
house.
which
Yeah,
is
yeah,
very,
yeah. That house is the
high-end.
premises.
That premises network was shown in the previous figure, how it looks like. Okay.
Okay.
Okay, then from the premises network only, you have these connections. You can see the neighborhood network. So before in the
Yeah,
premises
yeah.
network, when your premises network, actually the billing and other things is happening. So there is a smart meter also there. Okay. Then from that premises network, you have the wide area network from where the power is coming. So left
Okay.
hand side, extreme left is showing the power generation, transfer, and finally it is reaching to a particular locality, that is the premises network. So herein, if you look at this premises network down there, there is communication technologies. Okay. So
Yes,
how
sir.
so the medium was due to the network architecture. And network architecture was based on these premises network, wide area network. So you have this path, now road. Now how to transfer the information? The information can be either in the form of wireless communication or in the form of wired communication, that is called wireline communication, or it can be in the form of optical communications. Okay.
Okay.
So in when you come to the wireless communication, so you have these five types of communication. Okay. One is VPAN, VLAN, VMAN, cellular network, satellite communication. If you go to wireline communication, like wired, there in the earlier days you had phone which were wired. Okay, that
Yes, sir.
wired phone, that is like based on the phone line technology or the coaxial cable. And there's one more technology that is called power line technology. Okay, this is also in the form of a phone only. And nowadays you have these fiber systems in place. That is the optical communication, that is based upon the optical passive optical network and synchronous optical network, and different type of networks based on the optical fiber and carrier ethernet. So this is basically how the communication technologies are utilized.
So,
Okay.
yeah.
So now first thing I told you that we had these three. If you see, because this needs a bit of visualization. First thing was about the
Right.
network architecture, right?
Yeah.
So in the network architecture, we saw we had three things. Number one was premises network. Under the premises network, we had
Was
HAN,
home area network, building area network, and industrial area
area,
network,
yeah, and after that we had neighborhood network
neighborhood network,
and
which
wide,
had basically neighborhood area network or field area network.
and then we had WAN also. Okay, after that
Yes, sir.
we
Wide area network.
after that, once we are done, then we have the communication technologies that would be used. Now if you look at these devices, what happens is that depending up see if you look at the see depending on the specific environment. Okay, This what happens is that in the premises network you have divided into HAN, BAN, and NAN. The NAN and FAN, that is the neighborhood network or the field area network. What it does is that
Yes, sir.
it connects to smart meters. Okay, can I move this to the next slide?
Yes, sir. Yes, sir. You can go to the next slide.
Yeah. See, I in the last 10 minutes now, that problem, some DC sweep, AC sweep, now I want to revise that problem for you. Okay, in a
Okay, sir.
very, very simple form, so that you should
Okay,
not
sir.
forget. If you are not revising, I want to revise that part because
Okay, sir.
this theoretical part is easy. I think you can do it. Okay, but the yeah, wait, one second. Where what was I telling? Yeah,
Sir, we were talking about how it finished van.
yeah. So NAN and FAN connects to smart smart meters. What does it connect? It connects field devices primarily, field devices and and
So,
distributed resources. What happened? Okay,
nothing, sir.
okay, no. So, and what does this WAN do? WAN is the wide area network. It provides long distance communication links. WAN provides
Long
long
distance.
long distance communication. How much time is left here? You tell me. Like I want to do that.
Sir, I can't see that, sir. No, it's not
Okay.
written.
Now okay. Yeah. Now another 20. So last 10 minutes we will revise that part. Okay. So
Okay, sir.
what WAN does is WAN provides communication, long distance communication between the various enterprises. So WAN is basically provides long distance communication links between the grid and the utility core network. Basically its role is to provide the link between the and see, if you look at the diagram there and the premises network to the WAN network, your complexity will increase. Why? Because due to the size the WAN of the WAN network, due to the increase in size, okay, and the coverage area. So complexity increases from where? Complexity increases from where to where?
Van to van.
From no, from premises network to
To NAND and then NAND to van.
to
Like it's increasing
to
order.
yeah, to WAN. Okay, so okay. Now the second major part was in the grid was the communication. So now we have seen the network architecture. Now what about the communication? Okay, because there are so many enterprises. There are
Okay.
private enterprises, there are government enterprises. They have to follow one protocol only. If they don't follow one protocol of power sharing and power dealing, everybody has to compromise there. Okay,
Correct, correct, correct.
everybody is there to make money. But
Yes, sir.
in order to make money, there should be some coexistence. There should be some common path only. Then only everybody. If somebody will tell I will price at this rate, they can do that, but accordingly, they have to follow some rules and regulations. Okay.
Okay.
Now, for that company, first we will go to the communication technologies part. So we have the wireless communication. So in the wireless communication, the first communication will employ the radio frequency. Okay. So
Okay.
so the communication in the wireless communication, we have this radio frequency we have. So this radio frequency, what it does is that it acts as a medium of interconnection between the nodes in the network. Okay, it acts as an interconnection interconnection between the nodes in the network. The nodes in the network. So this is the primarily role of the radio frequency element there. So this, see, if you look at the radio frequency, it's a wide range of frequencies. Okay. So you see the FM, AM, amplitude model, so your wide range of frequencies, because of that only your radio is operating, different channels are coming. So this spectrum is,
Um,
yeah,
so, so could you wait 1 minute, sir? I'll
no,
just be back. I need to change my pen.
okay, no
So
issue,
one second, sir.
no issue, no issue. Then I think we will do that problem. Huh? I want to revise you that this part we will do nicely tomorrow. I wanted to revise that part because I want you to do it. Okay. I will show you with two iterations because that question is more important. I'll wait.
Hello, sir.
Hello. I think can we do that backward forward sweep one more time once
Yes, sir.
with
So,
with two
do you want
iterations?
us?
Yeah, yeah.
Okay, sir.
This theoretical part na. What I will do is that in tomorrow's I will make some because you are looking at that this thing and all na.
Yes, sir. Yes, sir. Yes, sir. I understand.
I'll make some PPT. Okay, on PowerPoint I'll present so that
Okay, sir. Thank you.
you will be able to now let's do this problem because on PowerPoint now it will take some time. I did not find time, but tomorrow is Friday. I'm not having no tomorrow is Thursday, right?
Yes, sir.
Tomorrow is Thursday. I'm having the whole session is not there. Tomorrow we have one exam duty. Then I can do it. So I'll find the time to
Okay.
do PPT. I want to give you the best. Okay.
Yes, sir. Yes, sir.
It is not just okay. I have a class or something like that. I want you to see here also because now time. How much is there? Yeah. Okay. Now look at that problem. I'll just see. I'll make the
Sir, same problem as what we've done in notes, or
uh,
different problem?
no problem. No, see values we can change or see backward. No, I will tell you the steps how to do. Like the notes I will give you for that. Okay,
Okay.
so that you understand this properly. I will do it with two iterations.
Okay.
Okay, two iterations. It can power flow. So the first point here was to like here I'll write down whatever notes I've sent you now. I'll make the PDF also. I
Yes, sir. Yes, sir.
I just I was busy today. Okay,
Yes, sir.
calculate calculate the current of each load. Write the steps. So see in your notes it is very complicated. I saw it. SN
Yes, sir.
VN conjugate. Right. First step is this. Second step is to calculate the current of each line. Calculate the current.
Sir,
You already have this.
are, sir, are you writing something? Because I can't see any ink, sir.
You're not able to see any ink.
No, sir, nothing. It's just plain white.
Yeah, I'm writing now. Yaar. Why you are not able to see any ink?
Sir, can you please reload it, sir?
Yeah, yeah, yeah. No issue, no issue. Yaar. Why it is happening like that? I'm also. Where is that share part? Since when you are not able to see, you did not tell me. From the very beginning, you are
No,
not.
sir, just now. No, just now, sir. It was. I was able to see when we were talking about the communications. We took
Now,
a new page from there on.
now you are able to see.
Are you writing something, sir?
No, 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 no. Now you are able to see the page.
Sir, page is visible, sir, but nothing is written there.
Nothing is written there. I don't know. Wait a second, yeah. Wait a second. Mm, okay, now you tell me. Are you
Sir,
saying
yeah, this is visible. So that was visible, but the new page, nothing. Yeah, now I can see. Now
okay?
I can
Now
see. Now I can see.
calculate the okay. Now we can see now. Now
Yeah, yeah.
calculate the current in each line. You are able to see current
Yes,
in
sir. Yes, sir.
each line. Now, yeah, each line you will calculate the current. Okay, so see this current in each line would be representing the backward sweep. Okay, backward sweep. Okay, and here the current in each line starting from starting from terminal point terminal point. Okay, so when you are starting it from the terminal point you will write I n minus 1 the line. Okay, so now you see how simple I'll make this. Within 5 minutes you
Okay,
will
sir.
be able to understand this. Okay, so you should be able this problem if it comes you have to do it will come definitely. They don't have any alternative. Then once you have done this backward sweep then you have to go for the forward. Okay, then you calculate the voltage, cal calculate the voltage of each bus starting from the first starting from the first bus. Now you see first starting bus. I will just write the calculations part. Okay, don't need to calculate. Now if I have this part here, I had this network, right?
Yes, sir.
Straight away I had S3, I had S2. Okay, now I had this I12 dash, I had this as I23 dash, and I had this as I3. The first part would be to calculate the value directly. I'll calculate the value. Number one, I'll uh, save this PDF. The first thing would be step one. I'll calculate I3 is equal to S3 into V3 conjugate. So the initial value here was equal to V3 value was equal to 7200 at an angle of 0 degrees. So directly you have the value of S3, that is 900 minus J500 into V3 value is 7200 into 1000. Okay, because of the MBA. So you get this value as 143 at an angle of minus 29. Okay, so this is step. Okay, now you have this. Once you have calculated I3 is equal to I23. All right. So start
Yes, sir.
from the very beginning. Start calculating the current. Step two is calculate the current I2. I2 again would be S2 divided by V2 conjugate, right? So
Yes,
V2
sir.
S2 divided by V2 conjugate would be, this would be 1500 minus J750, okay, divided by 7200 at an angle of 0 degrees into 1000.
Yeah.
If you calculate this part, it will come around 232.9 at an angle of minus 26.57. Now you have calculated. Now see step one, step two. Now you have I12. I12 is equal to I3 or I23 dash plus I2. So you have these two currents. One current is 143 at an angle of minus 29 degree. Another is 232.9 at an angle of minus 26.57. So you get the value here for this I2. So once you get the value of I2, you get the value like 373.9 at an angle of minus 27.3 degrees. Once you get this value of IIL2, then you need to substitute here. Okay. Then you have to go for this. This completes your, okay, current value. After that, you what
Sir, one second, sir. Sir, one second, one second, one second, one second.
you calculate.
Sir, sir, I12 is equal to I23 iteration, I23 dash plus I2, right?
Yeah, write down. Then I will show you the iteration part.
Yes, yes,
Okay.
sir. I'm just writing down, sir.
Hmm?
I'm just writing down, sir. One second.
Yeah, no issue. Even if it ends, meeting ends, immediately I'll send you the link because this part I want you to understand. It is very simple. It is not that tough. Now this was for the, this forms the backward sweep. Okay.
Yes, sir.
This is the backward sweep. The only the name is backward sweep. If you can see, the KCL is applied in reverse. You can also apply in forward. Even if you are applying in forward also, you'll get the same answer, right?
Same, yes, sir.
Yeah, if you do like this, do like this, or do like this, or else you do like this, do like this, or do like this, one and the same thing will come, right? Okay. Hmm. Because I was at,
Sir,
uh,
uh, I3 equals to S3 by V3 conjugate, right?
yeah,
Uh, and that the dash report that is to that's to show the iteration part, correct?
no iteration. Now I will show you when iteration will start.
No, sir. What is the dash you put? Is that a whole conjugate or only for a conjugate for V?
No, whole conjugate, S3 conjugate, V3 conjugate. This is the whole conjugate. Dash is for the
So
whole.
basically,
It is
okay, so yeah,
it means S2 conjugate, V2 conjugate. Since
yeah. Okay,
this V2 conjugate, since one at an angle 0 would be equal to one at an angle minus 0 degrees.
Yes.
7200 at an angle 0 degrees would be equal to 7200 at an angle minus 0 degrees. It won't change. But if there is some other value, 7200 at an angle of 26 degrees, then this conjugate will become 7200 at an angle of minus 26 degrees. That thing you have to keep in mind, right? You have written this part. Finally,
1 second, sir. 1 second.
oh, no issue, no issue. I'll save, I've already saved this in PDF. This part you write, then I will show you the how the iteration starts. You finish this part, and then we will move to the iteration part and see how simple this is. Okay.
Yes, sir. We can go to the
Yeah,
next part.
yeah. Because like here in your notes also, I found it very complicated. Yeah, it is
Right, sir.
confusing me as a PhD scholar who has so many public. See, after that, now for forward sweep, when you start for forward sweep, what you will do is for forward sweep, you have this V3 value. Okay, there in the diagram only. This is the diagram. Fast I'm drawing. Okay,
Yes, sir.
this is the diagram. So you have this V1, V2, and V3. Okay, this you have Z12 and Z13. Now for V3, if you have to make V3 would be equal to V2 minus Z into I23. So this I23 basically, now if you have the value of this, so now what would be the value? Now what would be the value of this? Now if you put this primarily, you will put this as this V2 value. If you have to put, what value you will put for V2? V2 you have to calculate first, right?
Yes, sir. Yes, sir. Yes.
First you have to calculate the V2. V2 you will calculate from V1 minus Z conjugate of L2. Okay. So in order to calculate this, how you will do this problem is that first you calculate the Z.
Okay.
Calculation of Z is very important. First
Correct, sir.
first you calculate the value of Z. Z is basically the total impedance.
Okay.
Total This total impedance value would be equal to Z line value, whatever was that, 0.3 plus j zero point 0.6 into ohm per mile into length of line in feet divided by 5280. 5280 means, okay, feet to mile, or we can say mile feet to mile conversion. So you have to do this. So now in the first case, Z12 is equal to 0.3 plus j zero point 0.6. The first line was 3000. The second line is 4000. So in the first case, it would be equal to 3000 divided by 5280. And in the second case, Z23 would be equal to zero point 0.3 plus j zero point 0.6 into 4000 divided by 5280. So you have these values. Okay, from this particular case, you will get the values. So normally, okay, normally if you look at the first case, this value will Z12 value will get as 0.1705 plus j zero point 3409 after I did the calculation. Okay.
Yes, sir.
Okay, this is how you will get the this value. Now if you look at the first case for first iteration, now for the first iteration V1 you have assumed as 7200 at an angle of 0 degrees and minus Z12. Here it would be Z12 and line 2. So Z12 value you have calculated like this, you do 0.1705 plus J 0.3409, okay, into what? Into your I12, right? This I12. So I12 you have already calculated in the previous case. Multiply that I12. That I12 value is 373.9 at an angle of minus 27.3 degrees. So this is the value of V2. Now if you look for the V2, it will come around 7085.4 at an angle of 0.68 degree volts. Now, once you have done with V2, you can calculate V3. Now, when you are calculating V3, V3 is again V2 minus Z, okay, into